In this video, we're going to talk about something called the chelation effect. A chelation effect is something that's specific of some coordination compounds, and it would not hurt to know the etymology of the word chelate. If you go to an etymology dictionary, it will tell you that chelation or chelate comes from the word clause in Greek. So when we talk about chelation, it's because there are some ligands that bite, if you will. They have at least two ends, if not more, that bite the metal. And for whatever reason that we will explain, it's not whatever, actually, we will explain it right now, it's that chelation effect, that biting is way more stable than if the ligands come separately. So for example, you have here, in both cases, you have nickel X aqua, nickel 2 plus. In the one first reaction, it reacts with 6 ammonia to form this complex, and in here it reacts with ethylene diamine. It's a bidentate ligand. This is why it only needs 3. It's still octahedral, but it's a bidentate. So as you can already imagine, this is a chelate. It bites the metal. So let's look at the formation reactions for these complexes. This would not necessarily be formation because it's already in water, but in some cases it is. Notice that this one is the second reaction is way more stable that it's actually worth naming it as a different effect. What's going on here? Why is it that the formation of this complex is so much more stable than the formation of this one? Well, first let's look at number of particles. On the first reaction, you go from 7 particles to 7 particles. However, when your ligand has more than one tooth and can bite or has two claws that can grasp the metal, then you don't need as many ligands, so you go from 4 to 7 particles. This is what we mean that the chelation effect is entropic. Why is that? Because every time a coordination compound with the bidentate or tetradentate ligand is formed, typically it's entropically favorable because it has more particles in products, therefore increasing the disorder, as you well remember, and that will result in a larger equilibrium constant, in a more spontaneous kind of reaction. Okay, so this is something to keep in mind. I know it's just qualitative. We don't have the tools to quantify and predict the actual numbers, but every time you see the formation of a complex that contains bidentate or tetradentate ligands, this is a chelation effect, and that formation will be favorable. The kind of problems that we can ask you is, for example, if we give you a reaction, can you predict towards which direction the reaction will be, or which one is the most stable kind of complex? As you well know, the oxalate is a bidentate ligand that can actually bind, has 2 claws, if you will. This is your metal, and so it's a bidentate ligand and can bite the metal. So this means that just by counting the number of particles, you have 7 particles here, you have 4 particles here, you have the formation of this this complex that contains a bidentate ligand. This will be more stable. This means that the equilibrium constant will be the reaction will be displaced towards reactants. The equilibrium constant will be smaller than 1. This is the kind of question that you should be able to practice and at least be able to also explain why do we say that it's an entropic factor.